Hi everyone. Today we're going to talk about the collision between two spheres. If you have two spheres with a radius of r, those spheres are going toward each other with a speed v, and eventually they collide. And you want to figure out what is the maximum pressure during that collision. Well, you cannot consider that the balls are rigid. You need to consider they are elastic, because if you don't, well, the area will tend to zero and you will have a pressure that is infinite. So you cannot do that. And so you need to consider that the spheres are not rigid and they are elastic with Earth theory of collision. Earth theory of collision says that the elastic energy of two spheres that collide is equal to half k h to the power 5/2. And so where h is the distance, h as illustrated here, which is the overlap. And to better show that, here I show that the sphere has been compressed due to the collision, and due to the other sphere that is also compressed, and that's h better illustrated here. The other thing is we can compare that to a spring. The elastic energy of a spring is kh squared divided by 2, where I use similar variable here. And you can see that they are similar, but don't have the same exponent. So what is k? K is defined as follow. So you have k equal 4 square root of 2 over 15. Well, this equation here, where E is the Young modulus and sigma is the Poisson ratio and R is the radius of the spheres. So we want to know what is, well, you can use this equation here, which is conservation of energy, where you have the elastic energy and then the kinetic energy before and after. And here you have the initial speed and the mass of the sphere. So again, you know what the elastic energy is, and you want to figure out what is the value of h. So you replace all the terms, and the final kinetic energy is, well, dh over dt square times m divided by 2. And from that, where h is that value again. And so if you have a collision at a maximum pressure, moment of maximum pressure, well, dh over dt is going to be 0, because suddenly your particles are not moving when they have collided and they are the maximum pressure. So at that moment, you can say it's 0. And from that equation, you can deduce what h is. So you can isolate h from the equation. So to do that, well, you can rearrange the terms and eventually get the value of h. So by doing that, we figure out that h0, the maximum h at the maximum point of pressure during the collision, is this equation right here. So now, from this, where are we going? Well, we want to figure out what is the cross-section area during the maximum point of the collision. Well, the maximum compression, h0. You want to figure out what is that area. So to do that, what we can do is we can use some trigonometry. And so here I'm showing more clearly the sectional area during the maximum point of the area of the collision, which is pretty much a cross-section of the sphere at that point, approximately. And so we can use some trigonometry to solve for that. So let's do that here. So you have the cross-section and then the radius r, and then h0, and then r minus H0 is that little section there. And you want to figure out what is x, which is the radius of the cross-section area. So you can do some trigonometry, which is pretty much Pythagorean theorem. So by doing that, you can figure out what x is. I'm showing again the triangle so you can clearly see. So you're trying to isolate for x. So you can just do the Pythagorean theorem and figure out x is equal to this. And from that, you can figure out what is the area, which is pi times x squared. And you replace x, you figure out that's the cross-section area. And the pressure is F over A. So you know A now. You want to figure out what is F. Well, you can use the second law of Newton, which is F equal ma. And the acceleration is, well, the initial speed of the ball minus the final speed of the ball, which is 0, over the time for the whole collision. So you need to figure out what time is. And you can use, well, the conservation of energy, this time without the last term being 0, to isolate for dt. And if you do that, if you isolate dt from the conservation of energy equation, this is what you get. You get dt equal dh over that square root term. And then you can take the integral from 0 to t, and this is from 0 to h0. Basically, dh is integrated over that that amount. So the initial point of the collision to the final point of the maximum pressure, right? And you can figure out that you can do the integral. You will get some gamma term in there. And for people that don't know, well, I will simplify that term to 2.94 divided by 2 for the constant in front, and then this is what we get for time. And so you can replace that in the acceleration term, and A equal VI divided by T, and then multiply by M, you get F, and then divided by A, which is the cross-section area, and from that you get the pressure. So there you go. This is the theory for you of Earth's theory of collision. Please like, comment, and subscribe.